Children. First, just wanted to say awesome work on this quiz today. Everybody did just really well, but I wanted to review it because I know you have an exam coming up in my class, as you have finals in many classes, and I just want to kind of round out our whole set of ideas here. So I'm going to actually run through these solutions kind of in the way that you guys can kind of follow the answers and see what's going on. So, for example, this first question, again, I'm saying basically you see all these objects going around in circles, but you don't know why. And the answer to this question is actually that if you're going to use Newton's first law, objects in motion should go in a straight line at constant speed. So this circular orbit means something is making that force, even if we can't see it. And so what we conclude is some kind of disturbance like a black hole. Okay? Now, here we have an object that is moving in a flat surface and slowing down, so we're going to draw a free body diagram. So we have the normal on the box due to the surface. Some people put M. M or B is fine. Note M or B's okay. And then here's the thing. Because this thing's slowing down, remember, if something's slowing down, by Newton's first law, a force has to make that happen. And in this case, we assume that that's friction. So again, we have a friction here because the box slows down. Okay. Now, not only do forces make things slow down, they also make things change direction. And that's actually the point of question number 3. So I saw a couple of really good free body diagrams here. I saw people draw a normal on the car due to the earth or due to the surface of the road, and the weight of the car due to the earth. And you have a friction here, so this is no ice. And then what people drew for ice was they'd have a normal and a weight. Okay? And what I saw was a lot of interesting answers. A lot of people would draw a friction force. A lot of people would draw no friction force. So I want to make a note here. I'm actually okay with you drawing either, but in your explanation, here's what we need to say. Okay? On ice, less or no friction. Either one works for me. Okay? And on the no ice road, it's actually friction on the tires that makes the car turn. What's awesome is some people just said friction as a one-word answer, and that was just great. So moving on here, this is my favorite answer, and I saw a lot of people do this, and this is just great. People were just like, here's the force on the object due to the earth, and this is for all. Awesome. Now here, once I get the baseball moving, why does it keep moving? Doesn't there need to be a force to keep it moving? A lot of people said inertia, and then they'd go into Newton's first law, and they'd say object stays moving, a force has to stop it. Another answer I accepted, because we talked about it in class, is it has energy from the throw and no force needed. So that's all those are good. So there's no extra force. Now here. This question 6, these free body diagrams are to apply to this box in this situation here. So in all the situations, we need a tension and a weight and a normal force on the mass due to the surface. So here, and you know what? I'm just going to redraw this. A tension and a weight on the mass due to the Earth, and a normal. and here we've got the box at rest. Again, the three forces that apply. Some of you had this labeled as F, and that's okay. I'm totally fine with that. Now, if we're moving in a straight line at a constant speed, that means the forces must cancel. So there's got to be something that cancels this horizontal pull of tension. And we're assuming that the box just goes on the surface, so there's got to be a friction force going that way. Here, the box is speeding up, so there's no friction force. And in this last part, we've got a friction keeping it at rest because the box wants to go this way, but the friction keeps it still. So for number 7, they're the same. And here's why. In both cases, constant velocity or at rest, friction cancels the horizontal tension. So no net force on the object. So there's no total force on the object. Now for our free body diagrams, these were great. There's weight for all of these. And what was awesome was when I was going around the room, I saw a lot of people draw things like this, which is just great. So now we're going to have here, for the number 10, we'll have a force at an angle theta. And we did a normal on the mass due to the surface. Here, we're going to have tension like this, and we're going to have normal on the mass due to the surface. And then for this last one, we've got two normal forces. One from this surface here, and then the other from the floor, which is tilted. So I'll say that this is a normal on the mass due to, I'll call this 1, and I'll call this 2. So normal on the mass from 1, and normal on the mass from 2. So that pretty much wraps it up for our solution. So I would go ahead and study these along with your quizzes for the final, and you guys should be set for tomorrow. Excellent work, everybody.